Ever looked up at the night sky and wondered how a telescope turns tiny dots of light into entire galaxies, nebulas, and stars? Today on Knowledge Hub, we're breaking down exactly how telescopes work, starting from small beginner telescopes all the way up to massive space telescopes orbiting Earth. At its core, a telescope doesn't magically zoom into space. Its real purpose is to collect light, because distant objects are incredibly faint and your eyes can only capture a tiny fraction of the photons reaching Earth. The larger the aperture, the more light the telescope gathers, and the more detail it can reveal. In small refracting telescopes, commonly used by beginners, a curved objective lens at the front bends incoming parallel light rays and brings them to a focal point, forming an inverted image. An eyepiece then magnifies this image for your eye. Reflecting telescopes, which dominate modern astronomy, replace lenses with mirrors. A large concave primary mirror reflects light toward a focal point, where a secondary mirror redirects it to a camera or eyepiece. Mirrors avoid color distortion, called chromatic aberration, and can be built far larger than lenses, which is why professional telescopes rely on them. As telescopes scale up, optical precision becomes critical. Large observatories use mirrors polished to accuracy smaller than the width of a human hair, and many modern mirrors are segmented into dozens of pieces that must act as a single surface. Sensors continuously measure tiny misalignments caused by gravity, temperature changes, and wind, while computer-controlled actuators adjust the mirror positions in real time. Ground-based telescopes also have to deal with Earth's atmosphere, which bends light unpredictably and blurs images. To counter this, adaptive optics systems fire lasers into the sky to measure atmospheric turbulence, then rapidly reshape flexible mirrors hundreds of times per second to cancel out that distortion. When you move telescopes into space, an entirely new level of clarity becomes possible. Space telescopes operate above the atmosphere, eliminating weather, air turbulence, and light pollution altogether. They use the same fundamental optical principles as ground telescopes, but pair them with ultra-sensitive digital detectors that convert individual photons into electrical signals. These signals are processed, corrected, and transmitted back to Earth as raw scientific data rather than simple pictures. Many space telescopes don't even observe visible light. Some specialize in infrared to see through cosmic dust, while others detect X-rays or gamma rays to study black holes, supernovas, and extreme cosmic events. So from a small backyard telescope with a simple lens, to massive mirror arrays on mountaintops, to precision-engineered observatories orbiting Earth, the idea remains the same. Collect more light, control it with extreme accuracy, and turn it into information. So the next time you see a breathtaking image of the universe, remember, you're not just seeing stars, you're seeing ancient light, captured, corrected, and decoded by some of the most precise machines ever built. If you have enjoyed learning how the universe and technology really works, make sure you subscribe to Knowledge Hub for more deep dives behind the technology shaping our world. And as always, stay curious.